let's get started. So this is today's assignment, and we'll just jump right into it. And we'll do some review. There are 7 questions, and we will just go one question at a time, okay? So number 1 is all ready. So if you haven't, please take out your notes. Let's get started. I'm just going to let you guys be in charge of working on the problem by yourself first, and then we'll take a look at it. So number 1, let's work on number 1. So let me give you a minute. Is that enough? And please share your answers after you're done in the chat so that I know that you have finished it, okay? So let's work on number 1. Somebody came in. Okay, 21 students, that's good. If 1 minute was enough. Does anybody have any answer for number 1? Maybe let's give another minute. Okay, thank you, Crystal. Anybody else? Okay, how are you guys doing? Okay, so we've got 2 answers. Thank you, Francisco and Crystal. I hope many more people. You don't have to write it down. Type it in, but I'm hoping that more people are participating. So let's get started. So it is it a growth? Every questions you have to ask yourself, the very first question should be, is it a growth pattern or decay pattern? Is it growing or is it diminishing? Is it going down or is it going up? And definitely the keywords right here, it grows, right? It says population is growing. The word grow is there. So it's going up. Okay, so what do we have to do? So let's treat the 3%. The first step is you divide by 100, right? You convert percent into decimal form, and that will be 0.03. Is everybody okay on that? And what do you have to do next? You're going to add 1 in front of it. So 1.03. Why do we add 1 to it? 1 represents 100%. Right? Don't you want to keep all 100% of the people? And 3% more. So that's 103%. That's what you want to figure out. Okay. If 5,000 people, next year you only have only 3%. That's like a extreme reduction, isn't it? Right? You want to have all 100% of the people and 3% more. Okay, so that's why we need to add 1 if it's growing. Okay, and so that equation will be y equals 5,000 times 1.03 to the time is 10 years. Okay, and I've got 6,720. Or more precisely, 6719.58. But since we're talking about people, I think 20 will be appropriate there. Very good. Nice job. Okay. Did everybody get that? I don't know. I don't know. What do you guys think? I just need to find more better way to check on you guys and see if you're participating. But I don't want to have them turn in the camera or, but please participate, okay? Just to hope, so if you have any ideas of what other teachers are doing or what I can do, please let me know. Okay, number 2. Let's just give 2 minutes. All right, thank you. Some of you already are on number 2 and be done with it. Now, when you see the word investment, you automatically may think that it's growing, but you can actually lose your investment, right? And then that's what's happening here. The investment loses 13.5%. So is it a growing pattern or going down, diminishing? It's a growth or a decay? All right, thank you guys. Some of you already done. Thank you. It's a decay problem, isn't it? It's going down. And how do we know that? Because it says investment loses. That's not good, huh? You're losing 13.5%. That's quite a bit of money, a percentage. Let's see what happens to this investment. If you're losing 13.5%, you don't want to keep losing for 8 years, but let's say you just left it in the account. Maybe you forgot about it and it's losing 8 years in consecutive years. What happens? So when it loses, let's go over. What do we have to do? What's the step? Okay, so number 1 was growing, and this is the step. Step 1, you divide by 100. Step 2, you add 1, right? That's the step. But if it's losing, the first step is you're going to subtract 13.5% from 100%. And you will get, what do we get? 82, no, 80, 86.5? 100 minus 13.5. 86.5%. because you're interested in how much you still have it, how much you still have it. What is the rate of retention, right? You know that you loses 13.5%, but how much do you still get to keep it, right? And that is 86.5% is the rate that you want to use, okay? So you're going to subtract 13.5 from 100%, and then you get 86.5%. Now you're going to multiply that by 100. No, I'm sorry. Now you divide by 100, which you will get 0.865. And that is the rate that you're going to use. Okay, that's the rate. So initial value is 5,000. And then the rate is a 0.865 to the eighth power. And I trust that I've got 3 of the same answers. So I trust that that's the correct answer. It's 1567.11. To the 8th power. 111011. Okay, very good. Okay. So your $5,000 investment now is 1,500. Okay, so that's not a very good investment, is it? Because you're losing that money. Okay, number 3. Okay. Is everybody with me? Number 3. Okay, about 2 minutes. Let's give 1 minute to begin with. Now, number 3 and number 4 goes together. It's same question. However, number 3 is compounded annually, but then the second one is compounded quarterly. Okay. So let's find the difference. Which one is better? Which one is a better deal? Is it compounded annually? Now, compounded annually means just once a year. Okay, you don't need to divide the percentage by anything. Okay, so, just a normal growth pattern. But then quarterly, we have to do something, right? You don't have to worry about number 4 yet, but let's just focus on number 3. All right, thank you. Anybody else? Let me see a couple more answers. Does anybody have number 3? What did you get for number 3? All right. So let's get started. Thank you for those 2 people. Okay, thank you, Crystal, Haley, and Roman. So you're going to, it's a growing, okay? Suppose you deposit 1,000, it pays 7.2%. So it definitely is growing. So what do we need to do first? 7.2% divide by 100, 0.072, and then you add 1. Just a normal growing exponential growth pattern. So 1.072. Okay, that's the number rate we're going to be using. So it would be 1,000 times 1.072 to the 5 years to the 5th power. And you will get, what do we get? 7.2 to the 5. 1,415.70 or 71 cents. Okay. Just round it off. Very good. Nice job. Thank you to those who share the answer. Now that's once a year. So every 5 years, right? For 5 years, every year at the end of 1 year, you get the interest. And then the second year, at the end of the second year, you get the interest. And interest once a year. How about if it is compounded quarterly, meaning you're going to receive interest 4 times a year? So what do we need to do? Let's go lay out the plan, the steps, so that you know what exactly you need to be doing on the test. Okay. All right. Looks like Gentry has the answer already. Crystal, thank you. Is everybody clear on what to do when you see compound quarterly, compound monthly, compound? What else did we have? We only had 3 types of a compound interest problem. Compounded semi-annually, that's 2 times a year. Compounded quarterly, that's 4 times a year. And then compounded monthly, meaning that's 12 times a year, because monthly, there are 12 months in the year, right? So this one is a quarterly. So the first step, okay, let's lay out the step. The first step is that you have a percentage, 7.2%, you have to divide it by 4. So you're going to split the other 7.2% into 4 equal parts. So 7.2 divided by 4. And I get 1.8%. In other words, every quarter, meaning every 3 months, you're going to receive 1.8% of interest. At the June, you get 1.8%, and at the end of September, you get 1.8%. At the end of December, you get another 1.8%, and that's total of 7.2%, isn't it, for the whole entire year? Okay, so you're going to receive 1.8%. Now the steps are all the same. After that, you're going to divide 1.8% by 100, which is 0.018, and then you're going to add 1. So it's 1.018. That is the rate that we are going to use. Okay. Next, so the initial value is 1,000. The rate is 1.018. Now, what is the time? The common, obvious mistake will be to put 5, and that will be a wrong answer, right? Why is that? because now we are counting by quarter period. Okay, so in 5 years, each year, 1 year has a 4-quarter period. So 5 years, it will be 5 years times 4, which is 20 quarter period. So you have to put 20 right there. So it's 20th power. Let's figure out 1000 times 1.018 to the 20th power. 75. Yeah, very good. So which one is better? Compounded annually or compounded quarterly? Definitely compounded quarterly is better, isn't it? Right? Because you're earning interest of the interest that you've earned, and you are earning interest of another interest. And so it compounds, it accumulates a little bit better. Right? Is everybody okay on this? Okay. So I hope this laying out the step for just normal growth problem. This is the number one is the growth. Number two is the decay problem. And then this is the compound interest problem. Okay. But essentially, you've got 3 type of problem that you need to deal with. Okay. All right, let's move on. Number 5. I don't know why I didn't give the enough of a space there, but let's see. So let's work on that. Some of you already figured it out. Very good. Radioactive element decays. So here's the key word here, decay, meaning it's going down. It rots, right? Decay means to go away, to decay, to rot, to decompose, right? So radioactive element decays at the rate of 5% annually. There are 120 grams. How much of the substance remains after 30 years? So what do we need to do if you are dealing with a decay problem? Right here, take a look at right here what we did. Is everybody good? I'd like to see a couple more answers. Does anybody have number 5? Okay, we've got 2 different answers there. Let's see. Okay. So we've got 3 different answers there. You see that in the chat? That's okay, right? You learn from making mistakes. But I want you to pay attention to what you did, though. Okay. Yeah. Okay. So you found out, right? think it's going to be 25.7 or 25.8 per gram. Let's find out, okay? So it decays at the rate of 5%. So what do we need to do? First step, 100% minus 5%, right? And you can do that in your head, but I'm just merely spelling out so that for those who may not have that step yet, will know exactly what to do, okay? So that's 95%. And that is what we're going to use. So now we are going to 95% divide by 100 to convert into decimal form, which is 0.95. So that's what we're going to use. 120 times 0.95 to the 30th power. Okay. And you should get 25.8. 25.8 grams. Is everybody good? Francisco, would you take a look at your answer and what you did and try to see if you can get the number 25.8? Yeah. Okay, we've got 2 more questions to go. Okay. Now, number 6, the equation is already given. And I may ask you a question like this, okay? To interpret the equation, okay? So if you see the exponential growth equation, growth or decay, first you need to be able to tell what the initial value is. What's the starting number? Can you tell me that if you look at the equation? And starting number is going to be, thank you, it will be 14000. I don't even know what we are talking about. Maybe 14,000 people or $14,000. We don't really know. There's no story behind it. But the initial starting number is 14,000. Yeah. Now, next question. What is the rate of growth or decay? First of all, is this a growth or a decay problem? Is it growing or is it decaying? This is a decay problem, isn't it? Now, how do we tell that? Because there is no 1 in front of it. It's 0.92. It's 92%. Retention, okay? You don't get 100%. You don't get to keep 100%. You only have a 92%. So this is a decay problem because there is no 1 in front of it. Next, what is the rate of a decay then? Is it 92%? No, that's not how it works, right? So if you look at the decay problem, like right here, number 2, if you look at 0.865, does that mean what was the rate? It was 13.5%, isn't it? So how do we get from 0.865 to 13.85%? You kind of have to go backwards, right? I think some of you can kind of easily figure out what to do. But essentially, you do the backwards of decay process, okay? Now, the last thing that we've done is divided by 100. So I am going to 0.92, multiply that by 100, which is 90 2%, right? But then 92%, and then what did we do? You, I don't know, 100 multiplied by 100. And then I know it's 8%. What do we do? 100 minus 92. Yeah, are you guys okay? So you don't want to say 92% decay. That would be a wrong answer there. But it is 8% decay. Right? Because you're retaining, you're keeping 92%, right? So how much are you still? Wait a second. No. 92% retention. So 8% decay. Yeah. So this is 8% decay. What is the rate of a decay? And it's not 92%, but it is 8%. The other part of, because a 92% represents the retention. So you're losing 8%. Does that make sense? So when you take the test, you will definitely have a 92% as one of the choices, but this will be 8% decay. Okay. Is everybody okay on that? Okay, here's the last question. Okay. Just one more growth increasing problem.5分ぐらいで終わるから、そしたら help できるから。All right, very good. Yeah, that's what I have. Your starting salary is 34,000. Can't remember what my starting salary was for as a first year teacher 21 years ago. Are there anybody who wants to be a teacher? Anybody want to be a math teacher? Maybe not. All right. So it is definitely increasing. So what do we need to do? 2.5 divide by 100, 0.025. And then because it's growing, what do we need to do? We need to add 1. So 1.025. Okay. So that's the rate we need to be using. So 34,000 times 1.025 to the fifth power. Okay. And I think I've already done that before. Calculation 38467. 38,000. 80, 88 cents, which is not too bad. 2.5 increase. I think the teacher is around there, 2% increase. Yeah. I mean, some company doesn't even really give you the guarantee of an increase. Sometimes it depends on your performance, and I don't know. For public school teachers, they are getting roughly like a 2% increase, I think. Anyway. All right. Hey, what do you guys think of all the problems? Do you feel comfortable working on these problems? Again, you definitely have a growth. So here are the growth pattern. You divide by 100, okay? And then you add 1. That's the growth. If it's a decay problem, you have to subtract the percentage from 100 to get that rate of retention, and then you divide by 100 to convert into a decimal form. Okay, that's a growth and decay. And then you've got compound interest problem. If it's compounded quarterly, you have to divide by 4 the percentage. Okay, if it's compounded monthly, then you have to divide by 12. We'll do that a little bit tomorrow. Okay. Yeah, we'll do that little bit of a review tomorrow. Okay. And then I will just turn the rest of the time for you guys to do something. So that's pretty much it. I hope this review was helpful to you. Please make sure that you take a picture of this and then turn it in. Okay. Again, we will meet as a class tomorrow to do some more review. And then on Friday, we will take a test. Tomorrow is Thursday, right? Yeah. So we'll do some review, and then Friday will be the test. If you have any additional or any questions, please stay and you can ask me, talk to me. Otherwise, I will see you guys tomorrow. Right? Take care, guys. Have a great day. Thank you. Have a great day, guys. Very good. Thank you, Francisco. Have a great day. Let's stop recording.